This is the second lesson on transforming parabolas. The first one was all about moving a parabola left, right, up and down on the coordinate board and changing its shape. This lesson is all about writing the equations of graphs, of parabolas. So now we're talking more along the lines of how to use the information we have to write the equations of them. So writing an equation of parabolas given the graph, you're going to need three things. You're going to need to know three items. You're going to need to know h, k, remember that's your vertex, and you need to know a in order to write the equation. The reason being, this is the equation right here, right? And so the numbers that need to, the letters that need to be replaced by numbers are a and h and k. The x and the f of x also stay there. So we need h, k, and a. So the first thing you're going to do when you are given a graph, okay, so if you are given the graph, you're going to look at the graph and you're going to identify the vertex. That's the first thing you're going to do. So 3 is going to be my h, 4 is going to be my k. And so then it says substitute it. So I'm going to put 3 in for h, 4 in for k. So now my equation is going to say f of x equals a times x minus h, which is 3, squared, plus k, which is 4. Okay, just remember that when you're plugging in h right here, that if it's negative, you need to be careful to, you're subtracting a negative, so you're going to need to worry about your sign there when you're plugging in a negative. Step 2, identify a point on the graph and substitute it in for x and y. And remembering that y is also the same thing as f of x. So this says y equals a times x. Right now it says minus 3 squared plus, and I wrote k instead of 4, so let me fix that. Plus 4. So right now this is what my equation says, and I'm going to plug in, and I've chosen this point over 5 down negative 4 right here because it appears like it's crossing directly on that spot. So that's going to be a point on the graph. We're going to call that xy. So negative 5 and negative 4. So I'm going to plug those into my equation. So 5 and negative 4. So the y part is negative 4. So negative 4 equals a. X was 5 minus h, which is 3, squared plus k, which is 4. So you can see right now everything has been replaced except for a. And that's because in order to write the equation, you need to find a. We have h and k. And so we're going to use this extra point we have on the line, plug it in, and we're going to solve for a. So that's what we're doing here. Negative 4 equals a times 5 minus 3 squared plus 4. Okay, so we're going to substitute. We're going to solve for a. So 5 minus 3 is 2. Okay, so that's step 1. And 2 squared is 4, so now I have 4 times a plus 4 equals negative 4. I need to get the term with the a in it by itself, so I'm going to subtract 4 from both sides. So negative 8 equals 4 times a, and then I'm going to divide by 4. And negative 8 divided by 4 is negative 2. So negative 2 equals a. Step 4, now you have hk. We were given 3 and 4 for hk, and we just solved for a, negative 2. So the only thing you need to do now is substitute into the equation. So the equation of this parabola passing through the vertex of 3, 4 and through the point 5, negative 4 is y equals negative 2 times x minus 3 squared plus 4. Notice that when you write the equation of a parabola, just like when you write the equation of a line, x and y remain in the equation. When we were writing linear equations, y equals mx plus b, remember we always said you have to have the slope and you have to have the b. And then when you found them, you placed them in the equation, but you always left the x and the y, and you just replaced the other numbers. So that's what we're going to be doing here with the parabola as well. Okay, so we're going to go ahead and try another example. So let's scoot the page up. Okay, so moving the page up, we're going to start with 2 different examples. We're going to do an example where we are given the graph, and then we're going to do the example, and an example that we are not given a graph. So what do you do in both situations? So first, example with a graph, you're going to, again, this is very similar to what we were just doing. Start with y equals a times x minus h squared plus k. Again, this is going to be my vertex, so this is my h and my k, and this is a point on the graph. We're going to call that x and y, and we're going to plug all of that into the equation and solve for a. So y is -3 times a. X was 0 minus h, which is 2, squared minus 5, because it's -5. 0 minus 2 is -2 squared, okay, times a. The rest of the equation stays the same. -2 times -2 is +4, so I have 4 times a minus 5 equals -3. I need to get the term with the a in it by itself, so I'm adding 5 to both sides. 5 minus 3 is 2, equals 4a, divide by 4. 2 divided by 4 is 1/2, so a equals 1/2. Now I have everything that I need to plug into my equation, so remember I always leave the x and the y, so y equals a is 1/2 times x minus h, which was 2, squared minus 5. So this is the equation of the parabola given in this picture. When you are not given the graph, you will still be given information that we obtained from the actual graph. So someone will tell you, here is your vertex HK, and here is a point on the graph XY, and you're going to do it exactly the same way, whether you are given the picture or you're not. So y equals a times x minus h squared plus k. We're going to plug in what we know. Y is 4. A we don't know. X is 2 minus h, which is -1 squared minus 2. So I have a subtract and negative here. I need to remember that it's +1. 2 plus 1 is 3. So I'm going to have 3 squared times a. Okay, 3 squared is 9, so 9a minus 2. I'm going to add the 2 to both sides, and I get 6. I'm going to go over here. 6 equals 9a and divide by 9. So 6 and 9 are both divisible by 3. 3 goes into 6 twice. 3 goes into 9 3 times. So a is 2/3. Y equals 2/3 times x, and it's minus -1. So I'm just going to make it +1. X minus -1. Okay, that's how it became +1. And then -2. So here's the equation of the parabola. We were not given a graph this time, but we were given this information. That's how you find it. Okay. On the next page, we're going to talk about identifying the vertex and the y-intercept if you are given the equation. Okay. So a little different. This time we have the equation, and we're just going to derive some of the information from that actual equation. So here's how we do this. Identifying the vertex and the y-intercept. So I can imagine that most of you will be able to look at this really quickly and be able to tell me, knowing that y equals a times x minus h squared plus k, that you find your vertex here in the equation. If this is plus, that means that it was x minus -20. So remember I said h is always the opposite sign. I'm reminding you here. So the vertex is -20, and the k, since there's nothing written out here, plus or minus nothing, means that k is 0. So ta-da, we have the vertex. Pretty easy to do. Just grab it right out of the equation. Finding the y-intercept is also sort of simple in that we know the x value of the y-intercept is always 0. And so if x is always 0, y is going to be whatever we get when we plug 0 in for x and solve. So 0 goes in for x. Okay. -1.5 times 0 plus 20 squared. And 0 plus 20 is 20. So we have 20 squared times -1.5. Okay. 20 squared is 400, so f of 0 equals negative 1.5 times 400. And when you multiply negative 1.5 times 400, you get f of 0 equals negative 600. So y-intercept is 0, negative 600. Okay, so again, plug in 0, solve, and you have your y-intercept. Both of them are fairly simple process. It's a fairly simple process to do. So let's try one more with this example. Find the vertex and the y-intercept. So the vertex, remember, we're going to get directly from the equation. And here it's x minus. Here's our h, and the k is outside the parentheses. So I have 3.2 for the h and 0 for the k because there's nothing outside my parentheses. So I know that that's going to be a 0. So again, pretty easy. Grab it right from the equation. To find the y-intercept, we always know that the x-coordinate is 0, so we're just going to plug and chug. F of 0 equals 0.1 times 0 minus 3.2 squared. So 0.1 times negative 3.2 squared. Negative 3.2 squared is 10.24. And so it's positive 10.24, negative times a negative. I'm going to multiply that by 0.1 now, and I'm going to get 1.024. That is my y-intercept. So 0, 1.024. So pretty easy to do. HK comes right from the equation, and then plug and chug your 0 for your y-intercept. Last thing, converting from standard form to vertex form. Again, we need those three things, H, K, and A, but this time it's in standard form when it's given to us. So in the previous examples, they were already in vertex form. We could just grab HK right out of the equation and plug in some other point and solve for A. So this time given to us when it's in standard form is A. A is easy to find in this particular problem. We have 2 as A. So we're going to substitute that into the vertex form of the equation. So 2 is going to go here. Okay. And now I just need to find H and K. So we know in standard form to get H and K, which is our vertex, we learned that to get H, we do the opposite of B over 2A. And so A is 2, B is 10, C is 7. Opposite of B, so opposite of 10 over 2 times A. Negative 10 over 4 is going to simplify to negative 5 over 2. Okay. So I have my H, negative 5 over 2. The hard part is going to now be to find K, and that is where we have to plug in negative 5 over 2 into the equation and solve. So this is going to be a little tricky. 2 times negative 5 over 2 squared plus 10 times negative 5 over 2 plus 7. So trickiness, here we go. We're going to do negative times a negative is going to be a positive. So I'm going to go right over here. So I'm going to have 2 times negative 5 times negative 5 is positive 25. And negative 2 times negative 2 is positive 4. Okay? Plus 10, it's like 10 over 1 if I were thinking about fractions. And if you have a calculator, you can certainly do this with your calculator. So it's negative 50 over 2. That's what this becomes. Plus 7. So that's just the multiplication part. Okay, so we did 5 times 5 to get 25. Negative times a negative is a positive. 2 times 2 to get 4. That's how we got 25 over 4. We multiplied across the top here. 10 times negative 5 is negative 50. And across the bottom, 2 times 1 is 2. Now we're going to simplify. So again, we can do some crossing out or canceling here if I put 2 over 1, right? Because 2 goes into 2 once and 2 goes into 4 twice. So 25 over 2. is what I have here, 25 over 2. And if I add that, or I should say subtract it because it's negative, so if I do minus 50 over 2 plus 7, I get negative, this right here, negative 50 plus 25 gives me negative 25 over 2. And if I change 7 over 1 into halves, I multiplied by 2 here, multiply by 2 here, I get 14 over 2. So plus 14 over 2. And negative 25 plus 14 gives me negative 11 over 2. That is K. So as you can see, having a calculator to plug in all of this, as long as you use parentheses, should yield that, and you won't have to do any of this work as long as you use your calculator carefully and use your parentheses and put things in properly. You should be okay. So times x minus h was negative 5 over 2. So we're minusing a negative or subtracting a negative. That means plus 5 over 2 squared minus k minus 11 over 2. So there's your equation for standard form to vertex form. Some of them are nasty with fractions, so please be careful, take your time, ask, and we'll do more practice of those if you need to.